Okay, so how do we get or solve the equilibrium equations to get the equilibrium distribution where we have an infinite number of states? Well, as long as it's sufficiently nice, so basically we're going to look at the idea that we have an infinite countant number of states. But the main thing is that if we have the probability of going from state J to state K doesn't depend on where we are, but just the difference. That is that we have a homogeneous Markov chain. Then one of the ways we can do it is we can use difference equation methods. So let's go and have a look at an example where we have an infinite queue. So the states now is the number of people in the queue. The size of the queue increases by 1 by probability P. It decreases by 1 with probability Q. And it stays the same with probability 1 minus P minus Q, except the case where we have no one in the queue, then the probability, it stays the same as 1 minus P. When you think about it, you can, from this, get two equilibrium equations. We have our first one. It says that to get to state I, we can either start with one less and add one. We could stay the same with 1 minus P minus Q probability, or we could have one more and we could lose someone from the queue. And then we have our boundary condition, which is this one. So let's think how we're going to solve that. And we're going to solve it using a thing called a difference equation. So the whole idea is we're going to guess a solution, substitute it in and get it solved. And it's a matter of just knowing this. You might have seen it in second order DEs, a similar approach, but this is almost like the discrete version of that. So what we're going to do is, first of all, if we rearrange it, we can write our first equation, not the boundary of the first one, as P plus Q pi I equals P pi I minus 1 plus Q pi I plus 1. And we're going to assume that the solution is going to be that pi I equals some m to the power I. So if we substitute that in, we get P plus Q m to the I equals P to the m I minus 1 plus Q to the m I plus 1. What we're going to do is we're going to divide by m to the I minus 1. So that's going to give us P plus Q to the m equals P plus Q to the m squared. And we can rearrange that to Qm squared minus P plus Q m plus P equals 0. And this is just a quadratic equation, and we can solve that, and we can factorize it into m minus 1 and Qm minus P equals 0. So we've got two solutions, either m equals 1 or m equals P on Q. So the general form is going to be a linear combination of these two. So the answer is going to be that pi I equals some constant A times by P over Q to the I plus B times our other solution 1 to the I, or just plus B. So we've got two constants here, A and B, that we'd like to solve. So the first thing we're going to use is we're going to use the boundary condition. So we know that we've got P0 equals 1 minus P pi to the 0 plus Q to the pi 1, which implies if we rearrange and simplify, P pi 0 equals Q pi 1. Well, to get pi 0, we can just go to this and substitute in I equals 0. So that will just give us A plus B equals, and we got a P times that, Q, and to get pi 1, we do the same thing again, but substitute I equals 1. So we've got A P over Q plus B. And if you simplify that, we should get AP plus BP equals AP plus QB, which gives us BP minus Q equals 0. Now we're going to assume that P is different to Q. So our solution to that is that B equals 0. Okay, so we've got B and we've simplified it. Now we need to think about how we're going to get A. So what have we got so far? We've got that pi I equals A P over Q to the I. So how do we now get A? Well, we can use our normalizing equation. So what does that mean? It means if we sum from 0 to infinity, pi I, that equals 1. So substitute in, we've got I equals 0 to infinity, we've got A P over Q to the I equals 1, which is A, the summations I goes from 0 to infinity, P over Q to the I equals 1. So further to assuming that P does not equal Q, we're actually going to go further and we're going to assume that Q is greater than P, so this thing will actually converge. What does it converge to? It converges to A 1 over 1 minus P over Q equals 1. And so A equals 1 minus P over Q. And so our final solution is pi I equals 1 minus P on Q, P over Q to the I. And that's it. So there's more than one method of doing this, but there's a nice simple method using what we call a difference equation. Okay, that's all of it. See you next time.